This is the screencast for section 6.4, example 1, exponential growth and decay. Now, some of this is going to be a pre-calculus review, but then other problems we will be definitely using some calculus in there. Example 1 is definitely a calculus problem. You can see dy dx solving by separation of variables. So it says solve for y if dy dx equals xy squared, and y equals 1 when x equals 1, so we will be able to solve for our c value. Well, first things first, dy dx equals xy squared, and it says my goal is to separate the variables to be able to solve. So first I'm going to distribute that squared over the multiplication, and now I have to separate the variables. So I have a dy and a dx on the left side, an x squared and a y squared on the right side. So I'm going to multiply both sides by dx to get rid of the dx on the left side. And then I'm going to also divide by y squared, or multiply by 1 over y squared, to get rid of the y's on the right side. Which leaves me with, on the left, 1 over y squared dy, which equals x squared dx on the right. Alright, so now let's take the antiderivative of both sides. Now if you remember the left side here, this will be y to the negative 2. So that would be now y to the negative 1 divided by negative 1, so negative y minus 1. Equals, and now the antiderivative of x squared is 1/3 x cubed, and then of course plus c. Now, why do you have to have a plus c on the right but not on the left? Actually, we do have a plus c on the left and the right. It's just what we did was then, maybe you wanted to call the left side a and the right side b, subtract both sides, and now you get one big constant over here on the right. So it's basically like we moved the whole constant over and combined it into one big constant. Alright, so now we want to solve for when y equals 1 and x equals 1. So I plugged in 1 for y and 1 for x. Solve for c. And I get to plug that back in to the expression I have, but the expression isn't solved for y. So I've got some work to do. It's a negative y to the negative 1. So first I'm going to divide everything by negative 1. And now I have y to the negative 1, so it's pretty much asking me to take the reciprocal of both sides, so that's exactly what I'm going to do. I'm going to raise both sides to the negative 1 power, which gives me y on the left, and then 1 over my expression that I had on the right. Now you could go ahead and multiply through by 3 over 3, and get a new expression for this, y equals 3 over negative x cubed plus 4, which is a little bit simpler to deal with, but it just depends on what your multiple choice answer is or what would suit your needs best. The now try problem number 1 says use separation of variables to solve the initial value problem. Indicate the domain over which the solution is valid. Oh, okay. So dy dx equals x over y, and y equals 2 when x equals 1. So I'm first going to separate those variables. I'm going to get all the y's on the left side and the x's on the right side. So that means y dy equals x dx. Basically, I multiply both sides by dx and both sides by y. So let's take the antiderivative of both sides, and I get 1/2 y squared equals 1/2 x squared. So similar antiderivatives. And then of course your plus c. Now we have a c value we can solve for because y equals 2 when x equals 1. So I'm going to plug in the initial value there and solve for c, which I get 3/2. So I can plug that in to my expression. 1/2 y squared equals 1/2 x squared plus 3/2, but I didn't solve for y. So I need to multiply both sides by 2, which means everything gets multiplied by 2. And then I'm going to take the square root of both sides. Don't forget your plus or minus. So now y can't equal both positive or negative square root x squared plus 3 because that wouldn't be a function. It wouldn't pass the vertical line test. You'd have a square root up top and a square root down on the bottom there. So instead, I'm going to take out those symbols and not use the plus or minus. We're just going to use the positive version, y equals x squared plus 3. Now, as far as the domain is concerned, I know you can't take the square root of negatives, but any negative plugged in is going to get squared first and then turned into a positive value. So in this case, the domain is all real numbers.